everyone, and welcome to today's AI in Space webinar. So, I see that we have a bunch of audience today, and well, I would like to interact with you. So, let me see your enthusiasm, guys. Just go ahead and write anything in the chat section. Maybe like, yay, what's up, hello, anything. Show your excitement for this particular webinar. My name is Soutik Nandy, and I'm currently Director of Technology as Spaceonova, and we shall be beginning the webinar shortly. I'm pretty sure today's webinar. So am I. So let's see your enthusiasm, everyone. So let's see how excited you are for this webinar. If you're as excited as I am or not, let me just go ahead and see it in the comment section. So that is how we can interact with you guys. So just go ahead and write down in the comment section how excited are you for this particular webinar. So let's see those comments coming up. I see that there's one by Mr. Munna Kumar who is by hello all. Well, hello Munna. Great to have you for this webinar. Let's see which many people there in this meeting. Um, all right, so I think we have a good number of responses. So I'm pretty sure this is more than excited. So well, for this particular webinar, we'll be expecting two, three things. The first thing which we'll be expecting today is that we would be covering up very briefly about what are the various applications in the world, what is AI in general, firstly, what is AI in general, what are the present applications of AI in the space sector as well. That is also which we would be seeing today. And also along with that, I'll also take you to the hands-on coding where you can go ahead and you'll see a short demo of our path planning where I was showing about if or how path planning can be used to avoid obstacles and plan out their way from a start till the end stage. So that is what we are going to see in today's session. So I hope that you all are excited. And without wasting any more time, so let's just go ahead and get started with today's session. All right, so let me go ahead and share my screen till then. And let's see. Okay, there we go. I have the screen. And, uh, right. I think that my screen is visible. I hope so that my screen is visible. And I think my screen is visible. Um, 1 second, just let me have a quick look. Thank you so much for informing me that. For us, it seems that the sound quality was not good enough. So I hope that my sound quality is now better. If you guys can confirm, I think that would be good enough for me. And if my sound is good enough or not. If it's not, let me see.
Yeah, if it's not, let me see that if, or in case I want to change my mic or not, just let me know. And with that, we can maybe begin. All right. So I think these are some little technical issues which, yep. All right. So that is great. Thank you so much for the confirmation. All right. So hello, everyone. And let's begin with today's session. I hope you guys are all excited. But before I go ahead with all the technical part and all the things about AI and machine learning and the coding and the rest of the things, it's first important to understand that what is Spaceonova and what are we. So, well, Spaceonova, or we have a dream, a vision that by year 2025, each and every member of this nation should have enough resources and guidance to pursue careers in the field of space sciences, irrespective of their background. So, just like Dr. APJ Abdul Kalam stated his vision 2020, we have stated ours. Now, the question is, are you with us? Let me know through your actions and contributions, and you already have taken one step by attending this particular webinar. And thank you so much for going ahead and attending this particular webinar. So, that is our Space Nova. And well, if you take love and innovation transformation, and cosmic. Put all the four things together. What you get right in the middle is Spaceonova. That is what we are, and that is what we stand for. Now, let's proceed forward. And in this slide, I have a sentence which says that your network is your net worth. Well, what is the meaning of that exactly? Well, the statement is quite self explanatory, meaning that your network is what determines your net worth. Or, in other words, your net worth is determined by your network. So those are the two words and a little wordplay here and there of your network and your net worth. And what is that one tool in today's generation which is focused, or which is completely, or which is more dedicated towards your building your network? I think you guessed it right already. That is nothing but LinkedIn. That is this one tool which is mostly for going ahead and networking with people. If you guys are not on LinkedIn yet, please go ahead and create an account. That's a very handy tool, and it will go and it will help you in increasing your network, which is the first step to kickstart your journey in this sector. So, how will you kickstart your journey? Well, at the very beginning, well, we already have covered up networking right over here. So, a little brief on this particular picture, whatever we are having, a little brief on that. So the two people which you are seeing on the picture are, on the left hand side we have Mr. Shivam Kumar Singh, who is currently the founder and CEO at Spaceonova. And on the right hand side, the person whom you're seeing, he is UAE's first astronaut. They both met each other in IAC Dubai. So you guys can also go ahead and participate in conferences and go ahead and network with people, since you get a lot of things from networking. You get to interact with professionals, you get to know what are the skills directly from the professionals themselves, and you also get some real life insights again from the experts themselves. Once you have once you have completed the first step, that is networking, you now proceed forward to the next step, that is training program. Go ahead and take any training program, um, uplift yourself, upskill yourself, take more training programs or any course to increase your skill set, so that you are now capable of conducting independent research and participate in conferences. You can go ahead and participate in there are multiple conferences available, and we'll also help you guys in participating in these conferences as well. And once you have done and even research, participated in conferences, you are now ready to step into or bagging an internship or participating in various space theme competition, which brings us right in front of you. As you can see, we have SSC, which is nothing but the Space Science Challenge, which is organized by Space Nova. It's an annual event. Well, we also have Space Science Challenge right now. It's starting just day after tomorrow, which is just 19th of May. We are starting with the second edition of the Space Science Challenge. It will be a great so it would be great to see all the teams coming together and competing in this space science challenge. So you are also welcome to participate in the space science challenge. In case you want to know what is the link, I mean, where can I register for the space science challenge? Even I'm interested for that. So the space science challenge, you can register it at ssc.spaceonova.com, which is, I think you can see right down below my screen. You can see sc.spaceonova.com. There is a link which you can go ahead and register for the Space Science Challenge. You can go ahead and register for that. So now that we have covered up the internship and space theme competition, you are now proceeding forward to the next step, that is learning a foreign language. Before that, I forgot this particular picture. So this picture is of a boy, Sumit. He is 11 years old, and he bagged the first prize in the satellites category of SSC 2021. Can you guys imagine? I mean, if Sumit can do, so can you. Even you can go ahead and participate and win the first prize in maybe satellites category or rocketry category, or we have another category which is the space robotics. You can also go ahead and participate in any of these three categories or all the categories depending upon your interest. And which brings us to the last step, that is learning a foreign language. You learn any foreign language so that you get a good understanding of their culture, and it helps you in communicating better. All right, so we have taken up what is the initial part of the initial aspects. Now we can proceed forward and we can now focus on concrete AI. Okay, so what is AI? Well, I would answer that question of what is AI, but I want you guys to also maybe take a guess on what is AI. I mean, the full form of AI, let me tell you, is artificial intelligence. So you cannot give that as an answer. Apart from that, you can give any other answer. Until the time you're going ahead and writing down the answers of what is AI, I would proceed forward and show you guys a picture of yeah, I'll show you guys a picture of a robot, and you guys have to take a guess as to who is this guy or who is this person. All right. So, well, the image which you're seeing, I'm pretty sure that you guys know this person. He or this guy or this robot is from the movie Interstellar, and its name is Stars. TARS. Stars. From the movie Interstellar. He stars from the movie Interstellar. So this is what we can say to get started onto what are the various applications of AI in the space sector. So now I'll show you guys a picture, and yes, you guys are aware that this is the first picture of black hole which was taken. Well, Well, this is one picture. I mean, this is an old picture. Now we have a new picture of the black hole at the center of our galaxy. I'll try to change this image from the black image of a black hole to the latest image, which was now taken. But nevertheless, I'd like to take this moment and explain you how this entire image has been generated. So this image of the black hole was generated using an algorithm which is known as the which is known as the chirp algorithm. Well, chirp algorithm stands for continuous high resolution image reconstruction using patch pairs algorithm. So this is the algorithm which was used in developing this particular image, which is an Bayesian algorithm, and it performed deconvolutional on images created in the radio astronomy. The development of chirp involved a large team of researchers from MIT's computer science and artificial intelligence department. The chirp used the image data from the Event Horizon telescope, which was originally too large for them to handle. So they built in, or they had to use several modules to scale or to process this image. And these modules, they are the famous modules in Python, which is NumPy, Panjas, and other such such modules were used in developing this particular image. And when NumPy came to know that it was being used in the development of this black hole image, it actually went ahead and created a blog for you guys to visit. So this is the blog for you guys to visit upon. Okay, yeah, this one, right? So this is the blog you guys can visit. This is numpy.org/case studies slash black hole image, which would have all the information about how NumPy was used in generating the image of the black hole. So this is the link which you can go ahead and visit. Now that we have seen the image of the black hole, which was constructed using AI, and similarly the black hole, which is at the center of the galaxy, was also created recently. So you also have seen that image as well. So now we'll come up to various other applications of AI, and they are the first picture of the person which you're seeing right in front of you is um, is Vyomitra. All right. So she is Vyomitra, or her name is Vyomitra. She is, or she would be used to function the onboard Gaganyaan, which is a crew orbital spacecraft. This lady robot is equipped with a head, two arms, and a torso, and is built to mimic crew activities inside the crew module of Gaganyaan. So that is the main usage of this lady robot, Vyomitra, which is a robot which is being built by ISRO, as you can see right over here. Next, we'll come up to this particular image, and this robot is, or his name is Simon. Yes, he is a he, because of its voice, which is of a male robot. I mean, it's the robot, or the voice of the robot is a male, so therefore he is a he. And so this device is an AI-based assistant for astronauts, which was developed by Airbus and IBM, and received some funding from the German Space Aerospace Center as well. So it has microphones, it has a camera, it has, yeah, so it has some air vents as well on its body, with the help of which it can go ahead and levitate, or it can go ahead and float in microgravity conditions as well. So Simon is equipped with that. So it has been, or this image is actually taken in the inside the ISS. So it has been sent to ISS as well. So now the next robot which you're seeing is the world famous robot known as the Astrobee, which was developed by NASA. So this robot is capable of surveillance and transporting objects from one point to another point. It's a cube-shaped robot, and it has, I think, over here it has two hands with the help of which it goes ahead and picks objects and moves them from a position to another. So that is the main utility of this robot, the Astrobee robot, which was developed by NASA. So that is one more robot which has its great utility and great usage in space. Now, the next image which you're seeing, yes, you guessed it right. This is the image of the moon. Yeah, this is the image of the moon, and the process which I'm referring to is the INS, or which is nothing but the intelligent navigation system. So now what exactly happened in the intelligent navigation system is that in 2018, that is about 4 years back, NASA, with the help of Intel, developed an AI system that helped astronauts find their way on planets. So this new navigation system would help in, yeah, so this navigation system would easily help in help yeah, this navigation system will help in easily navigating the surface of the planets to the shortest possible routes. And scientists have applied this program onto our moon. And the way the system works, that it simulated the entire moon surface and then compared the same with the local environment. So the AI would was trained with millions of moon's images and then used a neural network to create a virtual moon's map. So that is exactly how this intelligent navigation system worked, and the same algorithm was then used to the Mars exploration program as well. Now, another great application of AI, which is very useful in the today's realm, is the debris problem. So, to overcome this problem, scientists are using deep learning to enhance the accuracy of laser ranging techniques, which was traditionally used. So, they used a back propagation neural network model for pinpointing the location of the debris. It was also mentioned that after improving the pointing accuracy of the telescope through deep learning technique, space debris with a cross sectional area of 1 meters per squared and a distance of 1500 kilometers can be identified accurately with the help of this algorithm. So this algorithm is still being improved more and more and more to get, or to pinpoint the debris and predict the path of the debris as well. So we are using all these things as well to overcome the debris problem, to overcome the space debris problem. And now I'll come up to the last application of AI, that is the swarm wars or swarm intelligence. So, swarm intelligence is one of the most computational intelligence technique which is mainly used for solving of complex problems. So, swarm intelligence actually involves collective study of the individual behavior of population interact with one another locally, how they behave or how they interact with one another locally is what is the meaning of swarm intelligence. So the small robots which you are seeing right in front of you, they are known as agents. Okay, they are known as agents, which was used, or these agents follow very simple rules. They do not have any centralized control structure which dictates how they should move. Rather, they have or they behave at their own will, following those simple instructions given to them. Now now what happens is that they actually work with a certain random degree, and these interactions between agents lead to the emergence of an intelligent global behavior which the agents are themselves unaware of. How interesting is this? How interesting is this that they are doing a task and they themselves don't know what task are they doing. They are being a very simple task, but on a whole, as a collective, you would see that what is or how they are helping in solving the complex problem. Now, I'll come to the main definition of what is artificial intelligence, and I think you've taken a lot of time in writing down the question or writing down your answers of what is the meaning of artificial intelligence. Now, artificial intelligence, the word can be easily split into two, which is artificial and we have intelligence. This can easily be split into two, artificial and intelligence. Artificial means that it's man made in nature, and intelligence we have different definitions of intelligence which may differ from an individual to individual. Some might say that intelligence is the ability to create thoughts, or the ability to take decisions or to solve complex problems. Well, um, one such definition of intelligence is that it's the ability to adapt, perceive, learn, and achieve a goal from stimuli and logic. So, that is one such definition of intelligence, which might differ from you all as to what may be the definition of intelligence. But this is one such definition of intelligence, that is the ability to adapt, perceive, learn, and achieve a goal from stimuli and logic. When you put all those words together, you get a new definition of artificial intelligence, which is the science and engineering of making intelligent machines. That is known as artificial intelligence, which was said by John McCarthy in 1956, which is, well, quite a long time back. And there's one more definition by Mr. Richard Knight, who said that is a study of making computers achieve goals and perform tasks that humans do better at the moment. Both have their own perspective of what artificial intelligence is, and I believe that we have achieved a long way from what they actually thought in 1956. Well, it's not that long if you uh, think carefully. It's just 70 years down the lane. That is not quite a lot of time difference, but yeah, we have exponentially increased from where we were in 1956. Now, let me move forward and help you guys with the components of artificial intelligence, because that is something which we see a lot in these days. That is, there are a lot of things happening. We have artificial intelligence, we have machine learning, we have NLP, we have so many things, but we don't know that how all of these fit together, right? We don't know how all of these fit together. So, I would like to explain you with the help of a simple Venn diagram how these different components of artificial intelligence fit. Now, we have AI as a whole, which is a used subset, which is a used set, and under that you have machine learning, which is a subset of artificial intelligence. Now, if you go further and if you take another subset of machine learning, what you get is deep learning, which is a subset of machine learning. So first we have artificial intelligence, then we have machine learning, then we have deep learning. Okay, so these are all the subsets of each other. That is AI, then machine learning, then deep learning. So these three are the subsets of each other which we are having. Now, if you take, or now you must be wondering that, all right, Satvik, I understood that what is artificial intelligence and machine learning and deep learning, but what about natural language processing? How does that come into picture? Well, natural language processing is actually yeah, it's actually a subset of AI, but it also includes machine learning and deep learning as well. So natural language processing also includes machine learning and deep learning, but on an overall, it is an component of AI, or it's a subset of artificial intelligence. So I hope that these three terminologies are clear. But then again, someone asked me that, all right, Sathik, I think you understood, but where is data science? Okay, so where is data science? Is that data science is another subset of, or it's not actually a subset, it's basically a very different set from artificial intelligence, but data science includes machine learning and deep learning and artificial intelligence as well. So that overall is data science. Well, you can complex it more further and further by saying that this is data visualization, this is data mining, then you have data warehousing, then you have maybe data cleaning, and then you have, I don't know, there's so many things which you have and which you can make this Venn diagram complex and complex. But let's keep it like that, short and simple and sweet. Let's keep it like that, which is short and sweet, which is much better. Let's not complicate things further. Let's keep it like that, and this is now much more better. So now I hope that you guys have gotten an understanding of what is artificial intelligence and how does artificial intelligence, machine learning, deep learning, natural language processing, everything comes together into one single part. Now, what we would do is that we would directly jump into a demonstration of how this is used. And one such demonstration, which I would like to show, is known as the RRT. What is the meaning of RRT? Well, we'll see what's the meaning of RRT. But this is how the RRT looks like. I know it's pretty much, what do we say? It doesn't look, or I think it looks very scary because there are so many, what do we say? Yeah, there's so many, I don't know what are these creatures. I don't know. There are some creatures, but don't worry. Let me help you by understanding that what is RRT. RRT stands for Rapidly Exploring Random Trees. So I just omitted this E. Anyway, so this is rapidly exploring random trees. That is the meaning of RRT. Well, it how it works is that it random, or it's a random sampling based algorithm, and it expands outwards like a tree. So in this example as well, I mean in this graph as well, if you can see that it kind of expands like a tree, it goes ahead and it has its branches from here. So that is how this RRT expands. It expands like a tree. How does it work? How does it work? Let's show how does it work. So let's say that over here we have your start and we have your end. So we have a start and we have an end, and we want to go from the start till the end. You might say that this is one such route, right? This is one such route. Or you might say that you know this is one such route, right? Or you might say that this is one such route, right? So there are so many routes which originate from the start point till the end point, but we don't know that which of these routes should we take to avoid any obstacles or not, right? We don't know how much, how what route shall we take. So there are multiple routes which we can take, and we would be using an algorithm which is the rapidly exploring random trees algorithm, or the RRT algorithm. How this algorithm works is that it is a random sampling based algorithm. So you have, or you take a random point into free space. Okay, we take a random point into free space, and what we then do is we draw a line. Okay, we draw a line from the random point till from the start point till the random point, and we see that is this line crossing any obstacle or not. If it is not crossing any obstacle, okay, well and good enough for me. Then what I do is I take a fixed distance from the point and plot a point right over there. So I take a fixed distance from the start and plot a point right over there, and I delete the existing point. This is what you will get. So I took the start point, I took another point, draw a line, saw there was something in between or not. Nope. Then took a fixed distance from the start and plotted a point. Now I will keep on repeating it again and again and again. So there you go. I'm keeping on repeating it, and slowly, one by one, we would reach our goal. So now that the goal has been reached, we can then make the line green, which means that this is the path I should take to reach from a start till the goal point. So do you see that how it actually expands like a tree? Yeah, so that is how it expands like a tree. So again, before we move forward, I'd like to explain you what is the tree representation. So since everyone is in a two-dimensional plane, so we have an x coordinate and we have an y coordinate and we have a parent. For this, it is x0 y0, x1 y1, x2 y2, x3 y3, x4 y4, x5 y5. Now the first node which you're seeing is the root node. So this root node does not have anyone above him, or it does not have a parent, so we make the root node the parent of itself. Then similarly we fill in all the table. Now for x1 y1, that is this node. For the x1 y1, the parent is 0, so we have uh, you know we have the parent as 0 for x1 y1. We have the parent as 0 for x2. The parent of 3 is nothing but 1. The parent of 4 is 1. The parent of 5 is 4. Now that is how we fill in this entire table. That's how we fill this entire table. And now what we would do is we would see this live. We see this happening live. How is this RRT working if we have an existing, or if we have a map with a lot of obstacles? You would see that how it actually moves from one point to the other point. That is what which we would be seeing in this particular example. So let me just go ahead and present my code so that you guys can have a look onto how is this working. So let me see if I can, just share my screen, and we would see the coding as well. So let me just stop my screen, and I'll go ahead and share your screen. So till the time, guys, if you have any questions, feel free to write down in the chat section so that I can take up these questions at the end of the session as well. So let me see that if I can. Yeah, I think I can present my screen. Yeah, I'll present my screen. And yep, that's it. So I hope my screen is visible. Yeah, I hope my screen is visible. And let me just zoom in my zoom in the code because it's too small. So yeah, much better. So that is the code which we are having. So we used a lot of modules. We have a module which is spy game. We have RRT graph and RT map as well. So basically what I have done is I have shown you, or I will try to show you step by step I try to show you step by step, path by path, from one point to other to other to other to other. So I'll be showing you in 4 steps, and every step is just an extension of the previous step. So that is how I would be showing you guys the entire RRG graph. So let me just start with the simulation as well and see how this work. So if we consider the base pi, so in this base pi we have defined the basic things which we would need, that is what is the obstacle, drawing of obstacles, and the rest of the things. So basically, if you see, right, so this is the first part where we randomly plotted obstacles, and we have plotted about 50 of those obstacles randomly into free space. We have the green color node, which is the start, and then we have a red color node, which is the end. So that is the start state, and that is the end state which we are having. Now that we have defined the start state and the end state, we can now proceed to the second step, where in this case I have increased the number of obstacles a bit. Yeah, there are hundreds of these obstacles. No, there are 50 of these obstacles. Perfect. So now what is happening in this particular or particular illustration is that I am plotting a point, and I'm taking another point in free space and trying to draw a line in making sure that it does not cross any of the obstacle. So you find out that this would keep on getting denser and denser, and it will simply avoid all the different obstacles which we are having. Yep. So it will avoid all the obstacles which we are having. It will keep on getting denser and denser, making sure it's avoiding all the obstacles which it is encountering in between. So that is how this second graph is looking like. So now if I move on to the third graph, in this particular graph, what we would do is that we would move from the start state till the end state and move up till 500 or about 1000 of these iterations. Now, if you see this graph carefully, do you see how this entire illustration went ahead? It started from the start and it went till the goal, but it expanded outwards in between, right? It expanded outwards in between. So let's see that once again, this illustration. So see how this is trying to cover up as much area as possible, and randomly plotting on points, taking a fixed distance, plotting another point, and then deleting the previous node. So that is exactly how this code is working, and this is the entire dense network which is being created. Now, we don't want the iterations to go on forever or go up till and how many? I've just written 1000. If I give it like 2000, I don't want it to go ahead and just do up to 2000 iterations, right? I mean, see, this is just 1000 iterations which we did last time. This is 2000 iterations. So, what is the guarantee that how many number of iterations should you do so that you should be able to reach the goal state? There's no such defined iterations, right, to read from the start till the goal state. We need to stop as soon as we reach the goal state, and once we have reached the goal state, we would backtrack all its location to go back to the starting point. So in this iteration, what I would do is that I will make it things a little slow, and we would see this particular algorithm. So now do you see how is this working? Listing random points and then plotting a point in free space, then drawing a line and then cutting it in half. And oops, I think it went a little overboard. let's hope it wait. Let's hope it goes back to the goal states and not go wander somewhere else. Yeah, I think it's going towards the goal state. Oh, come on. Let's hope it works. Let's hope it works. I think it's trying to reach towards the goal state. Well, I have, or to make sure that it always reaches towards the goal state, I have added a biasing node. Biasing node means that after every 10th iteration, it will go back to the point where it will go ahead and have a look at the goal state. That is the biasing which I have done. Okay, this took a lot of time because I think the biasing was way too much. So if I go ahead and increase on decrease the biasing from 10 to just 5, which means that after every fifth iteration, it will start to move towards the goal. Let's see that how this path planning algorithm works. Okay, it's a very bad start state to go from, but nevertheless it'll keep on it'll try to find out the path from the start till the goal state. So let's hope that it does. I think it's going towards it. Okay, so I think it's already reached. There you go. This is the start and this is the ghost and this is how it reached. Well, I have slowed it down to a lot, and if I did not slow it down, if I just do it at at its normal speed, do you see how fast it goes? It reaches within a matter of seconds. Again, there you go. A matter of seconds. That is all it took to reach from the start to the goal state. Again, it's just taking matter of seconds again and again. And if you want, I can go ahead and okay, yeah, one more time. If you want, I can go ahead and increase the number of obstacles from 100 to 200 obstacles. So we had 100 obstacles, now we had 200 obstacles. And now do you see how dense the obstacles are? But it's still trying to find a way to go from the start till the goal state. And let's hope that it reaches the goal state eventually. There you go. It reached the goal state eventually. And it took a lot of time, but yeah, nevertheless. So it went from the goal state, and let's go ahead and again see how for 100 obstacles, and let's increase the dimension of the obstacles. Let's increase the dimension of obstacles from 30 to 40. That means these are a little bigger obstacles, and there you go. It's again okay. This was very clever. It took a roundabout and then reached from the start till the goal state. It went a roundabout and reached from the start till the goal state. Now let's go ahead and you can play around with these as much as you want. Don't make it very difficult for the path planning algorithm to work. It should work in most of the scenarios. It is trying to work in most of the scenarios. In some cases, it might fail, like in this case, okay, yeah, I think it will reach. There you go. It reached from the start till the goal straight. So make sure that you have appropriate biasing, because sometimes if you make the biasing way too low, it is not getting a chance to expand into free space. Give it a chance to expand it into free space so that biasing can happen. It's fine that if it takes a lot of time for biasing to happen, but yeah, you can go ahead and make sure that the biasing is not too low, not too high. Give it a chance to expand it into free space. If you give it too much of biasing, what happens is that or if the biasing uh, interval is way too high, what happens is that it will never reach the goal state because it is keep on expanding and expanding and expanding. If the biasing is way too low, what would happen is that it will again not get a chance to even expand. Now these all scenarios are failing because it's not able to reach the goal state, and that is because it is not able to find a proper path because of how difficult this maze I have prepared. But yeah, it is all random, and yeah, you can go ahead and play around with. So that is how one such application of how you can go ahead and utilize into free space, because we have a lot of obstacles in space, and we would like to find out what is the least possible path, or maybe not the least possible path, but a path from the start till the goal state. This proper or this arachi does not give you the least path at all, or it might give you the least path, but the reason why we use RRT is that it's way fast. It's faster than all the rest of the algorithms, because rest of the algorithms try to give out the optimal path, which increases the time complexity. But this one doesn't do so. It does not. Yeah, it does not increase, or it does not take a lot of time. It actually does things way quicker. So I think, yeah, I think that is the major advantage, or that is how we use in space. Munna, I think I was coming to that answer only, that how are we able to use our chi for the foreign space applications, because we have a lot of obstacles. We have craters, we have downhills, we have uphills, and every time, if you want, I mean, there are a lot of obstacle avoidance technique where you can just fit in IR cameras or sonic cameras, which would then just to simply detect that if it's an obstacle, take a right or take a left. But you, or is there any guarantee you reach the goal state one now? No, right? There's no such guarantee. But this IRT gives you a guarantee that if you go from the start till the end point, you would, or most probably you would find out the path from the start till the end in least amount of time. That is a guarantee which RRT is giving you. Rest of the algorithms, they do give you the shortest path, but it takes quite a lot of time for it to work upon. There are two such algorithms. One is known as the heuristic search algorithm, which means that it knows what is the map. In this particular scenario, it also kind of knows the map, but it does not know the complete map, because it is randomly plotting points from its space, right? It's randomly plotting in points and seeing that which where I can go. It is not a heuristic algorithm where, in case you are aware of the uh, you're aware of the topography. That is not in this scenario. You're not aware of the topography, but still you're able to reach from the start till the goal state. Now this RRT, exactly, it's not complete in nature, because there might be some downhill areas where RRT is not able to find out. It finds out the path that you just go and go through the crater kind of thing, but you may not. The robot may not. The robot might fail. The robot might get stuck over there. That may happen. So this is one more path, but obviously this is not the final algorithm which can be used in path planning in space. We have many such algorithms. There are many simulations which get tested and trained before we deploy it on the space. All right, there are many such algorithms which are being tested, so you guys can have a look into that as well. Well, I think, thank you so much for asking that question, Munna. In case you guys have any other questions, feel free to ask me. And till the time you guys are asking your questions, I would then proceed forward to the last segment of today's session. So let me just go ahead and share my screen. And well, yeah, this is where I left off from. So now you guys must be wondering that, all right, Satvik, I think I had a pretty good understanding, but how will I take it forward? I want to learn more about this. So for that, we have Spaceonova is introducing AI with space applications training program from the 24th of May. It's a 1 month long training program, and I would be one of the instructors in AI with space applications. And along with me, we have Dr. Shreya Shatra, who is currently the co-founder and director of space technology at Spaceonova. Then we also have Mr. Shankar Amrutkar, who is the head of Earth observation and satellite applications at ASEAN Space UK. She is also one of the instructors for this training program. Then you have Dr. Tamir Blum, who is the CEO and founder of Kisui Tech Japan, who would be there for your training program as well. He will be taking up one of the modules for that. Then you have Mr. Andrew Prince, who is a PhD candidate at Chuhoku University. He would be also there as one of your instructors in AI and space applications. And it does not end. You have Arshad Murray, who is a PhD candidate at University of Rome, Chor Vegata, who would also be there as one of the instructors in your AI with space applications. So, well, is this the end? No, obviously not. You have one more such instructor, and he is Mr. Sandeep Dondial, who is a PhD candidate and a teaching assistant at IIT Bombay. So you have a chance of interacting and learning from the best of the best Space Nova is giving you. Well, now you must be wondering that topic. Okay, I think I had a fair understanding of what our instructors are, but I believe that it should be very costly, right? I mean, the entire training program, 1 month long, 30 days, it should be a bit costly, right? And well, the cost of this entire training program is 35,245 INR. But oh my God, Sathik, this is way too much. Therefore, for you guys, we have slashed it down to just 6,600 INR. Again, okay, did I hear that it's still too much? No worries. We have slashed it down further for you all because of the currently ongoing training program. So this or the other currently ongoing early bird offer. So instead of providing 6,600 INR, we are now giving you just 4,999 INR, just for the 999 INR for the training program. That is how much which we are offering. So yeah, so that is just it. That is the amount which you need to pay for the training program, which is just 4,999 INR training program. And but did I hear that it's still way too much, or in case you guys do not, or you guys do not have both 999 INR, no worries. There is one more such, or there is one more part where we have, that is masterclass. Well, in this masterclass, we or the original cost of this masterclass is 9,000 INR, but again, we are slashing you down to just 4,640 INR. Did I hear it's still way too high? No worries, we're slashing it down because of the early bird offer, and we are just giving it to you at 3,999 INR. That is the amount which you guys need to pay, not 35,000, not 6,000, just 4,999 INR in case you're interested in the training program. And for masterclass, not 9,000 INR, not 4,600, just 3,999 INR in case you're going for the masterclass. Now, you might say that what is the difference between the training program and the masterclass? The major difference between a training program and a masterclass is that the training program is complete in nature, where you have all the modules and you'll have a lot of problem statements and discussions and assignments and the recordings as well. But in the masterclass, you'll be just be provided with the recordings and assignments. You don't have problem statements, or you don't have the extra bonus sessions. Okay, so that is just a miniature version of the training program which we are offering you. For more information, you can obviously visit, or you can obviously visit the link for more information, which is nothing but spaceonova.com/AISP as AI with space application. You can visit that particular, one second, yeah, you can visit that particular link. So let me just go ahead and show you guys the link as well. So that is for Indians. And one more thing, offer lasts up till tomorrow. So this is, or you guys have today's day and tomorrow's day to register for the AI with Space Applications training program. And this is the link in case you guys want to register at spaceon.com/AISP, which you can go ahead and register for the AI with Space Applications training program or the masterclass. And for non-Indians, we are not offering it at 470 US dollars. It's just 79 US dollars for training program. And we're not offering it at 120. We're just offering it at 59 US dollars for masterclass. Again, offer lasts tomorrow. So right. So offer lasts tomorrow. So these are just the early bird offers which we are offering you right now until tomorrow. Thereafter, you remember the you remember I showed you some increased prices? Yeah, we would be having the increased prices after tomorrow. All right. So don't forget to register at spacenova.com/AISP for enrolling in the training program. And in case you guys have any questions, please feel free to answer them, or feel free to ask them in case you guys have any questions. All right, so I think, yeah, that would be it. And well, you were a lovely audience. I had wonderful time interacting with you guys and solving your questions, of if any. So this is some sneak peeks, and we'll be seeing you guys on the 24th of May in case you guys are enrolling for the training program. And don't forget to register for the Space Science Challenge as well at ssc.spaceonova.com. We are beginning from the 19th of May. That is the SSC, there's the Space Science Challenge, the Grand Space Science Challenge. We are back with the second edition. So feel free to register for the Space Science Challenge as well. So, well, I think that would be it. And, well, thank you so much for asking any questions. And in case you guys are watching a recording of this particular live session, please feel free to write down in the comment section, and we will get back to those comments as well whenever yeah, we'll get back to those comments very soon enough. So, thank you, Brogan Costa, for the wonderful session. Thank you so much. I hope you enjoyed, and we'll see you guys on the 24th of May. Till then, bye bye everyone. Take care and have a great day ahead.